Welcome to Choktai School of Advanced Chemistry. Free radical substitution mechanism. This mechanism is basically followed by the halogenation of alkane. When alkanes are halogenated, free radical substitution is basically replacement of hydrogen atom by the halogen atom. For example, when an alkane like for example CH4 is allowed to react with halogen like Cl2, we will get CCl4 and HCl molecules. The formation of CCl4 is the basic evidence that there is a replacement of hydrogen atom one by one by the halogen atoms. This reaction can also be done by heating in dark. A free radical substitution starts a chain reaction which takes place in 3 steps. Number 1, initiation step. Number 2, propagation step. Number 3, termination step. Now come towards initiation step. The initiation step of the reaction is the breaking of Cl-Cl bond to form 2 chlorine atoms with the help of UV light. The energy of one quantum of the UV light is enough to break Cl-Cl bond. Since both atoms are same, the Cl-Cl bond break homolytically and each chlorine gets its own electron. This can be shown like that. Cl-Cl bond break into 2 atoms, and this is the shifting of single electron to each chlorine atom. This is the half curly arrow that is used for the shifting of one electron. And this is a symbol of free radical. Free radicals are highly reactive species, so they are unstable. Free radical is a species that may be an atom or may be a molecule which contain unpaired electron in its last shell. For example, hydrogen atom that contain only one electron in its last shell, that is an unpaired electron, and same is the case the Cl or any other halogen atom that also contain one unpaired electron in its last shell. This can be justified by the help of its electronic configuration. For example, 17 electron in total. So the electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p5. If we split this subshell into orbitals, there are 3 p orbitals, px, py and pz. First we distribute one electron to each orbital, then the rest of 2 electrons with opposite spin. So there is one unpaired electron in p orbital of the chlorine atom. That's why this chlorine atom is said to be a free radical. So it is a highly reactive species. Propagation step. The chlorine free radical takes a hydrogen atom from methane to form HCl, a stable molecule, and this may also make methyl free radical. Cl radical, when react with methane, there is exchange of free radical by hydrogen atom. HCl and CH3 free radical formation takes place. Now this CH3 has become a free radical, so it has high energy. The next chance is CH3 radical will collide with unbroken Cl2 molecules. And once again, there is exchange of radical and a halogen atom. We will get Cl radical plus CH3Cl, a normal neutral species. So Cl radical, once again Cl radical has been formed. So it is highly likely to be occur that this Cl radical will collide with its own neighbor product. So I am going to write it again. Cl radical goes to once again exchange of radical by the atom, in this case hydrogen atom, HCl plus CH2Cl radical formation takes place. Now once again the free radical has been shifted on the carbon atom. Whenever there is a radical on the carbon atom, it will react with normal Cl2 molecule. CH2Cl, it will react with normal unbroken Cl2 molecule, and again there is an exchange of free radical by halogen atom, and we will get CH2Cl2 plus Cl radical. So in this case, once again there is the formation of Cl radical. As we have seen that whenever you are going to make Cl radical, then there is a chance for the recollision of Cl radical to the CH2Cl2 molecule. So Cl radical plus CH2Cl2, once again there is an exchange of radical and hydrogen atom. Whenever the Cl radical is in reactant, and there is a formation of HCl molecule plus CH, one less hydrogen, the other compound that has become a free radical, and we use this free radical again as a reactant. So CH radical Cl2, whenever there is a radical on the carbon atom, we react it with Cl2, unbroken molecule of halogen. Exchange of atom versus free radical, once again there is the formation of Cl radical, and we will get CHCl3 as a neutral molecule. And whenever you are going to make Cl radical as a product, it will recombine with its neighboring product. So Cl radical plus CHCl3, exchange of atom and radical, so we will get HCl plus CCl3 radical. Now the radical has been shifted on the carbon atom. CCl3 radical, it will react with the Cl2 to make CCl4 plus Cl radical. So in this way, all the hydrogen atoms are replaced by the halogen atom. Now come towards termination. In termination, as the name indicates, there is a termination of different free radicals. For example, Cl radical that has been formed from the initiation step, they combine together to make again simple Cl2 molecules. From the propagation step, there are CH3 radical, another CH3 radical. So in this case, we have the double carbon alkane. Alkyl radical and other alkyl radical goes to another alkane. And this is a specialty of this mechanism. In single step, you can make the double chain alkane. Now come towards once again the propagation step. Different species in the propagation step that has free radical can collide together to make a neutral normal molecule. For example, CH2Cl, CH2Cl, they combine, and this CH2 bond formation will take place, we will get dichloroethane as a terminated product, as a final product. And there are so many other possibilities. So many other possibilities. Of the termination. But you should remember at least these 3 steps as far as the Cambridge AS syllabus is concerned. Now come towards another option. How many different alkanes can be made in termination step? For example, if we are starting from ethane, CH3 bond CH3, this is the major ethane. In propagation step, there is a possibility for the formation of free radical on these both carbon atoms. So there is a formation of radical, for example, CH2, CH3. Another possibility is CH3, CH2 free radical. These are basically 2 radicals, but they are same. When they combine together, they will make a butane, normal alkane, 4 carbon alkane molecules, butane. That is known as butane, also known as N-butane. So only one alkane can be made at the terminating step of ethane. But if we are using propane in this mechanism, in this sequence, in this reaction, there are 2 types of carbons. One is the primary carbon, another one is secondary carbon. So as there are 2 carbons, so there is a possibility of 2 different free radicals. One of the possibility is CH3, CH2 and CH2, that is primary free radical. And the other possibility is there might be chance for the formation of secondary free radicals. So in the termination step, these 2 species can terminate it by reacting themselves or by reacting each other. So if 2 primary free radicals come in close in front of each other, then there is a formation of a longest chain compound that is known as hexane. If 2 secondary radicals confront to each other, then here is the bond formation takes place. So this molecule will known as 2, 3, 2, 3 dash dimethyl butane. Hexane, and the second one 2,3 dimethyl butane will form. There is also possibility of the third compound that can be made if we use one primary radical and other one secondary radical. I am going to make it over here. One primary CH3 CH2 CH2 radical and other one secondary free radical can meet together to neutralize themselves. So there is the formation of another bond, and in this case we will get a molecule that has the longest chain of 5 carbons and one branch that is methyl, that is 2-methyl pentane. Thanks for watching.